All right, here are the solutions to the redesigned practice test for the SAT Section 3. This is the second test up on their website. This is my first video on this test. I'm going to just do problems 1 through 5 in this video to keep it relatively short. So as you probably know, you're given all this information, and if I ever use this, I will refer back to it in the video. In this first video, I don't think I will. So this first problem, you're told that 5x plus 6 equals 10 and asked what is the value of 10x plus 3. Few different ways you can solve this, but probably the most straightforward is to solve for x over here. So you got 5x plus 6 equals 10. You want to be able to solve this linear equation. You want to get the x all by itself. So get rid of this 6 first by subtracting 6 from both sides of the equation. And then divide both sides of the equation by 5, and you'll get that x is equal to 4/5. And then what you're trying to do with that is figure out what 10x plus 3 is equal to if x equals 4/5. So you take this 10x plus 3, but instead of writing an x, you write 4/5. And then you're going to need a little bit of skills with fractions here. We're multiplying fractions. This is really a 10 over 1. And when you multiply fractions, you multiply straight across. You get 40/5, aka 8. If you don't want to do 40 divided by 5 in your head, you can cancel out this 5 in the denominator with the 5, that 5 times 2 makes 10 here. And you'll be left with the 2. 2 times 4 gives you 8. One way or another, you'll get 8, and 8 plus 3 is equal to 11. So answer C is the correct choice. I don't know that people would have really thought to solve it this way, but one other way you could solve this is you're asked for 10x plus 3. You're told 5x plus 6. We're almost there. This thing is almost half of this, right? The 5x is half of 10x. But I got 6, and really I'd like half of 3. I'd like 1.5. If 5x plus 6 equals 10, then I could subtract 4.5 from both sides of the equation. You might be like, why the hell would you do that? You're introducing fractions, or I guess decimals if I'm going to write it that way, which is kind of annoying, and yeah, I agree. But if you could subtract 4.5 from both sides of the equation, you'd get right here. And then you'd note that what you have on the left-hand side here is exactly half of what you want. So if 5x plus 1/2 is equal to this number, then 10x plus 3 is equal to twice this number, aka 11. Probably a little quicker this way, but I bet in the pressure of a test and all that, most people wouldn't think to do this way. Instead, just go through the green and the red. So yeah, I guess I'll call that good. Number 2, a system of linear equations is a problem that shows up. The type of problem shows up a lot on these tests. There's multiple ways to solve it. The way I like is this method of adding equations. I think most people's natural tendency is to do substitution, and that'll work out fine. And in this problem, it'll probably take you just about the same amount of time. But I like this adding equations method, so I'm going to show you that. The way I add equations is it really only helps to add equations if you can get rid of one of the variables, either the x's or the y's. So note that if I took that first equation and multiplied both sides of the equation by 2, I'd get 2x plus 2y equals 0. 0 times 2 just happens to be the 0 here. And if I leave the next equation alone, 3x minus 2y equals 10, then I can add the two equations together. 3x and 2x gives me 5x. 2y and negative 2y gives me 0. And then 0 plus 10 gives me 10. So the reason I doubled this first equation was so that these y's would go away in this next step. You have to kind of look into the future when you're doing these. 5x equals 10, well then x equals 2 if I divide both sides by 5. So I know that x equals 2, I'm done with the problem. Can't be this, can't be this, can't be this. My answer is B here. If you feel like checking your answer, you can be like, well, x plus y has to equal 0. So if x equals 2, y has to equal negative 2. Hey, that's exactly what it says here in B. In fact, if you knew that x plus y had to equal 0, you could immediately cross off A and D because that doesn't satisfy that first criteria. So you were down to B or C before you even started. If you plug those in, you'll see that the only solution is the one that we found. Number 3, this is kind of a twist on a linear equation, a linear price function. These show up a lot on these SAT tests. And so the idea here is a landscaping company estimates the price of a job using this expression, 60 plus 12 n h. So your variable in this case, you kind of have two of them. N is the number of landscapers, and h is the total number of hours. So what this is saying is that if you're going to get your yard done by these people, you're paying $60 no matter what. And then in addition to that, they're going to charge you $12. And they're going to charge you $12 every time h goes up by 1. But really, it's not $12, it's 12n every time h goes up by 1. And n is the number of landscapers who are working. So that kind of makes sense. You can think about it like each worker has to get $12 for working an hour. So if you have 5 workers, n equals 3, so then this is $60 here, and you get an extra $60 every time h increases by 1. Anyways, if you go through and read these, interpreting the coefficients on these problems show up all the time. And so in this case, the 60 represents the amount you'd pay no matter what, kind of the flat cost. And then n is the number of landscapers, and h is the total number of hours. So this 12 right here is the amount. Well, I'll read these. The company charges $12 per hour for each landscaper. That's exactly right. A minimum of 12 landscapers will work on each job. No, that's not true. The number of landscapers is n, and n can be any number you want n to be. The price of every job increases by $12 every hour. That's tricky. That's almost the right answer, but it's not. Imagine if n equals 2. If there's a big yard and you need 2 people working on it, then the price goes up by $24 every hour. This is correct if this said 12n, but it doesn't. It says 12, so it's not correct. Each landscaper works 12 hours a day. Now, what are you talking about? No. All right, number 4. Which of the following is equivalent to the expression shown above? A few ways you can get there. If you recognize that this is a perfect square, you can factor it. This is, let's see, I don't want to use a's and b's. This is some number squared, that number being 3a squared. And this is some number squared, that number being 2b squared. And then this is exactly twice 3a squared times 2b squared. So this is a perfect square, and if you recognize that this is a perfect square, you can immediately figure out that your answer is A here. But if you don't recognize that, what are you going to do? Well, one thing you could do is just kind of think about coefficients. If you were to square this first one here, you'd have to foil things out. You'd multiply sort of 3a squared plus 2b squared times 3a squared plus 2b squared. And if you were to FOIL, you'd multiply these two guys together and you get 9a to the 4th. Hey, that looks pretty good. You'd multiply these guys together and you get 4b to the 4th. That looks pretty good. And then the O and the I in FOIL, you sum those together and presumably they get you this 12a squared b squared. They do. But the reason I want to talk about it like that is think about, I don't know, C, for example. You'd have to FOIL that out. You take 9a squared plus 4b squared and square that thing, aka multiply it by itself. And I'm not going to bother to do it because, I mean, in the pressure of a test, you wouldn't want to expand all of these. But just note, if you were to FOIL these out, the F in FOIL would be 9a squared times 9a squared, which is 81a to the 4th, which is not what you have up here. Therefore, that cannot be the answer. The other two involve raising things to the 4th power. When you're raising things to the 4th power, it's even worse than FOIL. It's like 3a plus 2b times itself again, times itself again. And you definitely don't want to figure what this is in the pressure of a test. But note that if you just kind of think about it for a second, the F here would give you 9a squared, and the F here would give you 9a squared. And then the F, when you multiply this answer times this answer, the F in FOIL would give you 81a to the 4th. Again, you don't have 81a to the 4th. The answer can't be B. And D is even worse than B. It's the same idea where you're multiplying this thing by itself 4 times, but now the coefficient on A is a 9. So you'd get 81a squared times 81a squared. You'd get some huge number that would certainly not be the 9 on the coefficient. So rather than expand all of these out, sometimes you can just look at kind of the leading coefficient, this 9 right here. Just looking at this 9 right here was enough to eliminate 3 of these 4 choices. All right, number 5, this radical equation here. Solving these show up once in a while. It's a good skill to have. The basic idea when you're solving radical equations is you want to isolate the radical. So the radical is a little square root sign. You want to get rid of that thing. That's what makes this equation so hard to solve. So you're like, oh, right, square both sides of the equation. No, you can't do that. You can't square both sides of the equation. You can't get rid of the radical unless it's isolated. If you tried to square both sides of the equation right now, you'd have to do some ugly FOIL mess thing. So what you want to do is get that radical all by itself. Add x to both sides of the equation so things look like this. Then you can square both sides of the equation to get 2k squared plus 17 equals x squared. And what they tell you in here is that x equals 7. So really they're telling you that 2k squared plus 17 is equal to 49. That's not a 9. That's a 9, kind of. And you're asked to solve for what k is equal to. Okay, so subtract 17 from both sides of the equation. Fortunately, they make those numbers work out relatively nice. You don't have to borrow anything when you're doing that subtraction. I don't think that's a coincidence. I think they did that on purpose because you don't have calculators on this section. And then divide by 2, and you get k squared equals 16. So therefore k equals, wait a minute, there's two answers, plus or minus 4. Oh, right, k is greater than 0. Therefore, the only possible answer is 4 in this case. So one way to solve this is kind of the book method. This is exactly what a book would tell you how to solve this. This will work on any problem of this type. The only real trick is to remember to isolate the radical. If you didn't know this solving method, I suppose you could do some sort of guess and check thing here. I think the problem is purposely written to discourage students from doing that. I mean, try throwing in numbers. Try throwing in a 5. 5 squared is 25 times 2 is 50 plus 17. So now you're already up to 67 if you haven't made any arithmetic mistakes. And now you got to think about, all right, if I take the square root of 67, that's not a perfect square, so I don't know what I get. If I subtract 7 from that, would I get 0? Well, you wouldn't, because you'd need 49 underneath the radical in order for that to work. But that's a lot of thinking to do. That's a lot of kind of calculations. That'll take you a long time just to eliminate one answer from these 4. So really, this idea of solving these is probably the way to go if you can learn this little method here.